All right, let's jump right in. We all use data to figure out what's happening right now. But what about what happened last year or even last week? Today, we're going to talk about how to make sure your data's history is actually telling the truth. We're getting into testing type 2 slowly changing dimensions, which is, kind of the gold standard for tracking history.
So let me just ask you this straight up. Is your data telling you the real story about its past? I mean, think about it. An employee's job title, a customer's address, these things change all the time. If your data warehouse can't keep a clean record of that history, then your analysis, your reports, pretty much everything you build on it is standing on a really shaky foundation.
So, just to make sure we're all on the same page, let's do a super quick refresh. With type 1, when someone gets a promotion, you just overwrite their old job title. Poof, that piece of history, it's gone forever. But with type 2, and this is what we care about today, you keep that history. You create a full, auditable timeline of every change. So, how exactly is this history kept safe? Well, it's done through this really elegant solution known as type 2 slowly changing dimensions.
Honestly, the best way to think about a Type 2 SCD is as a time machine for your data. Seriously, instead of just erasing old information, it creates a whole new record every single time a key piece of data changes. It's like you're building this incredibly detailed diary for every single entity, which lets you go back to any point in time and see exactly what was what.
Let's look at a real example. Check out this table. You see two records for the exact same employee. The first one, software engineer, is now marked as expired. When they got promoted, we didn't delete anything. We just created a brand new record for senior engineer and set its status to current. See, nothing was lost. We just added a new chapter to their story in our database. But, and this is a big but, here's the catch. This amazing method can get really messy really fast if you're not careful. Without the right quality checks, you can suddenly find yourself with duplicate active records, these weird ghost records that show no change at all, and a totally bloated table that just kills your query performance. It can go from being a pristine archive to a hidden liability before you know it. So, how do we stop that from happening? Well, we need a toolkit. And this source material lays out 3 absolutely critical quality checks to keep our data's history clean and honest. Let's break them down one by one. First up, and this one is the big one, there can only be one, and only one, current version for any single entity. One employee, one customer, one product. It can only have one active record at a time. This rule is basically the bedrock of Type 2 integrity. It's non-negotiable. And the reason this rule is so important is that breaking it has very real, very serious business consequences. I mean, if an employee has 2 current records, they might get counted twice in a headcount report. A customer with 2 active records could get double counted in a sales region. See, this isn't just some techie glitch. It leads to analysis that is just plain wrong.
The good news is, finding these errors is surprisingly simple. This little bit of SQL right here is all you really need. It just groups all the current records by their unique ID, like an employee ID, and then that having count star greater than 1 part flags any ID that shows up more than once. It's a super direct and powerful way to hunt down these critical mistakes.
Okay, on to our second check. This one is all about efficiency. The rule is this: you should never have 2 versions of a record, one right after the other, that are completely identical, where nothing has changed except for the timestamps and the keys. So why does this matter? Well, because every single one of those useless records is just bloat. It makes your tables bigger, your queries run slower, and it wastes a ton of storage. It's like having 2 identical photos right next to each other in a photo album. It doesn't add any new information, it just takes up space. Now, trying to manually compare every column in tables that might have hundreds of them, that's just impossible. So the only way to do this is to automate it. The idea is to build a script that acts like a detective, comparing every single column in one version to the version right before it. Using something like the lag window function is perfect for this. It's designed to automatically flag any record that's just a carbon copy of the previous one. And that brings us to our third and final check: protecting the things that should never ever change. We're talking about your immutable attributes, those data points that, once they're recorded, should be set in stone. This is a really, really important distinction to make. Look, a change in someone's job title, that's a historical update. A change in their date of birth, that is almost certainly a sign of data corruption. Same thing for a product's original launch date. When these things change, it's not a simple tracking mistake. It's a huge red flag that something is fundamentally wrong with your data. And the logic to find this is pretty straightforward too. You basically just want to compare the value of that unchangeable field in one record against the next record for the same entity. If that value ever changes, if a previous birth date is not equal to the next birth date, boom, you found a serious problem that you need to investigate right away. So after all that, after running these checks, what's the actual payoff? Why does taking the time to keep a clean data history really truly matter? So you might be thinking, is this just a theoretical problem? Absolutely not. When the script for that second check, the one that looks for identical records, was run on a real-world data warehouse, this is how many it found. 6. 6 records that were complete, pointless duplicates, adding nothing but noise and bloat. It's solid proof that these aren't just weird edge cases. These are real problems that these checks can actually find and help you fix. And that kind of leaves us with one final thought. When you apply these 3 simple checks, you can start to make your data's past just as trustworthy as its present. So the big question you got to ask yourself is this: is your data warehouse a reliable archive you can truly count on? Or is it a hidden liability, quietly poisoning your decisions? The answer, as always, is in the details.